It is very difficult to shoot more than 20 billion stars through probably the biggest dark openings ever found in logical history. Dark openings have enthralled cosmologists and astrophysicists as much as some other enormous secret. The James Webb Space Telescope was utilized by cosmologists to cause a huge revelation that will to modify how we might interpret the size and extent of dark openings. It's possible that the in-question object has a mass between 2 and 4 million times that of the Sun. How much do we now know about these strange voids, and what did they discover? Come along with us as we travel through space. We believe that these black holes are quasar remnants due to their abundance, which was only discovered a few weeks ago. We ought to begin with a layout of dim openings preceding diving into the exposures made possible by James Webb's state-of-the-art equipment and intelligent endeavors. A great deal of issue are brought into an exceptionally limited space by dim openings, incalculable substances known for serious solid areas for them interest. Since dark openings look like unfavorable voids in the texture of the universe, even light can't get away from their gravitational force, which is the reason this peculiarity is in some cases alluded to as a gravity well. The ashes of massive dying stars typically form smaller black holes, which can be found all over the universe. Strangely, supermassive dim openings, which have vast masses between 1 million and 1 billion times that of the Sun, rule the point of convergence of essentially all tremendous frameworks. Despite decades of research, the origins of supermassive black holes remain a mystery. These Goliaths, which rule the focuses of systems all around the universe, entrance researchers, yet they battle to fathom the cycles that prompted their development. Be that as it may, increasingly more of the fact of the matter is being uncovered to mankind by the latest discoveries. As a matter of fact, Earth is really surrounding a dark opening in Sagittarius that is somewhere in the range of 2 and 4 million times bigger than our Sun. Scientists were thrilled when they discovered a massive black hole with a mass roughly 9 million times that of the Sun. This unimaginable finding was made possible by the James Webb Space Telescope, which viewed this as monstrous thing settled at the focal point of a world just a short time after the gigantic explosion. Beyond its undeniable size, this revelation is crucial because it provides new insight into the origins of these enormous monsters. The mystery surrounding the origins of these massive objects in astronomical history will be solved, and researchers are willing to accept that more of this kind will soon become apparent. Over the course of time, numerous revelations have been provided. Researchers have discovered 2 types of dark openings: heavenly mass dark openings and supermassive dark openings. Star mass dark openings, whose masses commonly range from 5 to multiple times those of the Sun, are remembered to frame when gigantic stars bite the dust disastrously. These stars experience a gravitational breakdown that completions in a grandiose blast impact when their nuclear fuel runs out. The main thing left in the result is a heavenly mass dark opening, a gravitational remainder of a once Goliath star's destruction. Supermassive dark openings are at the focal point of the greater part, while possibly not all, of enormous cosmic systems for a bigger scope. Because of their enormous size, these magnificent beasts, whose masses are between 1 million and 1 billion times those of the Sun, are beyond our current understanding. Their presence is evidence of the forces that shape the universe, and their origins remain a source of wonder and ongoing investigation. Bizarre outcomes from stargazing, in spite of the fact that it might have all the earmarks of being clear, the development of supermassive dark openings is everything except direct. Stargazers like Stephen Finkel from the College of Texas in Austin have found these huge dark openings, which have a mass that is in excess of 1 billion times that of the Sun and have existed for under 1 billion years since the enormous detonation. How they were able to grow to such size in such a short amount of time is amazing. Researchers are looking at the universe's distant past, which spans approximately 13.7 billion years, in an effort to solve this mystery. Anyway, it's not clear. Buildup can obscure the light from so far back, making the early dull openings inconceivably weak and testing to separate. It's like trying to solve a riddle using only parts of it to answer a question. However, astronomy's capacity to uncover secrets over time and explore previously unexplored territory is perhaps its most exciting feature. A galaxy contains CEERS 1019, a newly discovered black hole. CEERS 1019. A clever finding. This fascinating discovery was made as part of the Cosmic Evolution Early Release Science Survey, which looked at galaxies in depth. The goal of this project is to test and prove research methods. The review's information, which are situated in Boötes and Ursa Major, two notable star groupings, have ignited a great deal of fervor among cosmologists. The data assembled by JWST's SHARP might reveal insight into the mass, synthetic synthesis, and various other critical attributes that make this specific universe remarkable, revealing insight into parts of grandiose development that were beforehand obscure. Scientists can change how we see divine cycles and investigate the starting points of the universe through this assessment. They moreover found two extra-old supermassive dull openings, making this revelation not alone. The comprehensive CEERS review has fundamentally improved the comprehension of cosmologists. They recently discovered black holes in galaxies like CEERS 1019 by combining extensive spectral data with images taken by the satellite telescope in the near and mid-infrared wavelength range. As a result of the telescope's dumbfounding powers, stargazing research is moving from speculation to quantifiable reality. In light of its trend-setting innovation, we are presently ready to notice and research these occasions in phenomenal profundity. As light goes from a long way off enormous frameworks to Earth, it step-by-step becomes bent, is stretched out into longer frequencies, and pushes toward the infrared district of the reach. Keen cosmologists found the dark opening in Diviners 1019 by searching for splendid cosmic centers or dynamic cosmic cores, which are believed to be the main indications of dark openings that eat a ton of issue and deliver a ton of energy. Scientists, who had long assumed that early black holes were uncommon, were shocked to learn that JWST's initial observations revealed a large number of active black holes from the first billion years of the universe's history. The CEERS overview has demonstrated to be inestimable thanks to the JWST's exceptionally delicate infrared gear's uncommon potential. The one-of-a-kind person of these dim holes, according to a fascinating NASA official statement, Diviners 1019 is striking for its age and staggering lightness. This captivating dark opening is unquestionably smaller than the enormous dark openings observed further away by various observatories, which have masses greater than 1 billion times that of the Sun. Its mass is approximately 10 million Sun-based masses. As a starting point, let's look at the shadowy opening known as Sagittarius A*, which is at the center. It is approximately 4.3 times heavier than our Sun. This is much smaller than one would expect from a modern supermassive black hole, despite the fact that it seems like a lot. Appeared differently in relation to the more colossal dull openings as of late found, this new disclosure isn't as unbelievable. In addition, two additional celestial lights were discovered in the analysis. These were massive dark openings with masses that were not at all typical perceptions at such distances. These articles were framed roughly 1.1 billion years and 1 billion years after the huge explosion separately, and are arranged in the focuses of the system's CEERS 2782 and Diviners 746. The core black hole is also contained in CEERS 1019. At around 10 million Sun-controlled masses, all of these dim openings guides the galactic outcome. In any case, what does an immense heavyweight look like? For instance, the colossal article at the focal point of the universe M87 is 6.5 billion Sun-situated masses. In CEERS 2782, no irksome residue darkened James Webb's perspective on the dark opening, simplifying it to find. The bright accretion disk surrounding CEERS 740 SIXS black hole, on the other hand, partially obscured it, suggesting that it might be in a star-forming galaxy, which made it a minor obstacle. The results of the CEERS survey have made black holes even more mysterious and intriguing, and as a result, we now know more about a wide range of them. Researchers in like manner made a charming exposure at the point of convergence of their discernment. A supermassive dim opening, as demonstrated by the sign of rapidly moving plasma. Though this imprint was genuinely honest, the researchers' cautious generations and assessment allowed them to quantify weaknesses, giving them a definite 95% affirmation that this shocking component had been recognized. The team is hopeful about the future and anticipates that additional observations will lead to even more significant discoveries. The significance of this signal will only rise as new perspectives on black holes and the space around them emerge as a result of advancements in science and technology. After effects of the discovery, the ramifications of this finding are huge. taking into account that CEERS 1019 appeared only a brief time frame after the enormous blast. Intriguing considerations with respect to its start arise. A long-held logical hypothesis that supermassive dark openings framed when more modest ones blended is upheld by this startling finding. However, there's an issue: the dull opening in CEERS 1019 is enormous. There are only two possibilities regarding its origin. The principal situation proposes that CEERS 1019 may have arisen straightforwardly from the breakdown of a huge gas cloud, sometime before cosmic systems came to fruition. These gas fogs, 10,000 to 1 million times the mass of the Sun, were found in these fogs. Alternately, the disintegration of a star cluster might have formed the dark opening frame. As per the subsequent speculation, Diviner's 1019th seed dark opening began little yet immediately developed as it ate a ton of issue nearby. The vast majority of current dim opening hypotheses suggest that more unobtrusive dull openings ought to approach first in star bundles or universes preceding meeting to make the seeds of supermassive dim openings. However, if the new findings continue to produce similar outcomes, our understanding of how black holes develop throughout the universe may be seriously challenged. We have only just begun our investigation into the depths of the room, and so many secrets remain undiscovered. We eagerly anticipate what the James Webb Space Telescope will immediately reveal because it has proactively allowed us to advance our understanding of the universe. The massive shock that will follow is not far off. Appreciation for watching. What do you accept is the wellspring of these huge dark openings? Please share your thoughts in the comment section if it won't be too much trouble. Make a point to buy into this video and offer it a go ahead. The accompanying one will include you.